All right, so we're going to cover units 4, 5, and 6. Like I said, if you want to try to work ahead, that can be good. But as we go through it, I'll give little tips and reminders as we go along. If you're watching this video, I would recommend pausing and trying the questions on your own. But of course, that's up to you. And then same thing in class. Once in a while, I might stop and give you a chance to try a question. Let's dive into it. So this was the first unit of trig. Okay. What do we notice about this question? Yep.
Well, there's the secant instead of like.
Yeah, so it's a reciprocal instead of a primary ratio, right? The mistake that people make is they say secant is the reciprocal of what? Cosine. They say it's cos of, don't write this down, 4 over 5 pi. So they flip the angle, but this is wrong. Don't do that. Okay. What is the right thing to do is flip the whole thing. What's our next step?
Well, you can use gas to change it into negative cos pi by 4.
So how'd you get pi by 4 and how'd you get negative?
Well, because 5 pi by 4 is in the third quadrant, and that's where tan is positive, which makes cos negative.
Very good. So 4 pi by 4 would take us there. 5 pi by 4 goes one further, right? So, whoops, oh geez, I'm messing this up. There we go. So 5 pi by 4 is here. So our theta related is pi by 4 because it's one more pi by 4 past that. And again, in quadrant 3, cosine is negative because that's the tangent quadrant. Finally, pi by 4 is in one of the special triangles, so I'm going to draw out the triangle. Cosine is adjacent over hypotenuse, so it's 1 over root 2. Whoops. Negative 1 over root 2. And you can then flip and multiply or put it into your calculator, or if you just know that it's the reciprocal, then you're just flipping 1 over root 2 to become root 2 over 1, right? But it'd be like negative 1 over 1 times root 2 over 1 if you were doing the fraction math the long way, works out to negative root 2. That's the type where you're given the angle and you're searching, you're evaluating for the ratio, right? And it was exact value. This one gives you the ratio, gives you the result, and asks you to find the angle, right? So it's the other kind. Again, this is a reciprocal. It's cotangent. It's the normal domain. Everything on the exam is the normal domain. There's no negative pi to pi. Okay. There's two ways to do this. You can do it as cotangent, but it's a little bit easier to do it as tangent. So that's the first thing I'm going to do. So it's root 3 over 1, right? This is the other triangle. What's the common mistake that people make when they're drawing this triangle and labeling it? Anybody remember?
They'll put like pi over 3 at the top and pi over 6 at the bottom.
Yeah, get the pi by 3 and the pi by 6 in the wrong places because this angle is 60, and so in your head you're thinking 6 and you put pi by 6. Also, you think 6 is bigger, so it's the bigger angle, but because it's in the denominator, it's reversed, right? So this is pi by 3, this is pi by 6, 1, 2, root 3. That's something that it's been long enough since you've done that, and you might have to kind of review that and make sure you really remember how to label the triangle. Okay, and then tan from SOHCAHTOA is opposite over adjacent, so opposite and adjacent. Root 3 is opposite of pi by 3, so theta related is pi by 3. It's positive. So that's quadrant 1, which is just the related angle. And quadrant 3, as we saw again from the cast rule, we saw that before. I'm going to write it out again. How do I find theta in quadrant 3 from theta related? Pi plus theta related. So that's 3 pi by 3 plus 1 pi by 3 gives us 4 pi by 3. Pi by 3 and 4 pi by 3. Okay, write the equation of the graph. There is no graph. Oh, there it is. Remember, this is the kind of question that when you first look at it, it could feel kind of overwhelming, like, oh my gosh, where do I even start? What do I even do? Who remembers the trick to breaking this down into what this question is actually asking us to do, or what we want to have as our sort of target, our goal?
You need to find the A, B, C, and D values.
Right, A, so it's y equals A, this one's sine, k x minus c plus d. So I need to find A, K, C, and D. The order in which you do them doesn't really matter. It tends to be a couple of things that jump out at us. Sort of early on, they're easy to do, and that might be what you start with, but it's up to you. There's a little trick that I advised when we did this before that can get you started and help you focus and kind of make sure that you don't make some kind of little error. Anybody remember at all what I'm talking about? I think not, but. Draw in the 5 dots. Sine starts on the 0 line, so it's easy to find the 0 line because this is only one cycle. If it was more than one cycle, or if it was cosine, and if the squares were really small, people get the 0 line wrong, right? Draw in those 5 dots and then count squares to make sure everything is even. 1, 2, 3 up, 1, 2, 3 down, right? That has to happen. 1, 2, 1, 2, 1, 2, 1, 2. 2 squares horizontally between each pair of points. So I know I have the right points. When I count squares and I see that everything is equal, I know I've got the right points. Okay, what jumps out at you that we can start with? A, K, C, or D? What do you think?
Well, D is 1.
D is 1. That's often one that kind of jumps out at us, right? You might want to draw in the 0 line as well. Some people like to and some people don't. So D is 1. Good. Next. Go ahead.
C is 3 pi by 4.
How'd you get that?
Well, you can see it starts at between the pi by 2 and pi, and that would be half of pi by 2 is pi by 4, and it's 3.
Okay, very good. Yeah. So again, when you only have one cycle, the start is easy to find. You have to, if you're good at dealing with the scale and good at fractions and you can kind of do that in your head, then it's probably easy. But that maybe takes a little bit more work. The D value, you can usually just, you do have to look at the scale. We did have to notice that this is counting by ones. And amplitude often is quite easy as well. But the C value, it's easy to see where it starts. You just have to think about the scale. So the other way you can think about it is if it's 2 squares to pi by 2, then 1 square is half of that, which would be pi by 4. Or remember the other trick, which only works if pi is on the scale, which it is, count the number of squares to pi, and then 1 square is that. So it's 4 squares to pi, 1 square is pi by 4. Then we go 1, 2, 3, and we get to where the start is, so that's 3 pi by 4. Very good. Once you have the 0 line and you've looked at the vertical scale, the amplitude becomes fairly easy. So it's 1, 2, 3, and we're not counting by halves. Remember, that's what I'm talking about with the scale. You do have to kind of watch for that, but this one's just counting by ones. So the amplitude is 3. What's the other thing we have to be careful of when the amplitude is 3, but when we're looking at the A value,
Careful if there's any reflections.
Yeah.
It might be -3, although in this case it is just 3.
very good. So in this case, there's no reflection, so A is 3, but if there was a reflection, A would be -3. Amplitude is always positive, but the A has the reflection in it. And usually the last one that we do is K because it requires a bit more work, and by then we've already done everything else. How do we find K? 2 pi divided by the period. And we don't know the period, so that means we have to go and find it, but very good, because if you remember that formula, 2 pi divided by the period, you'll remember that, well, I got to find the period. And how do we find the period? The end minus the start. We already have the start. 2 pi is 8 pi by 4, 9 pi by 4, 10 pi by 4, which is 5 pi by 2, so that works. 11 pi by 4 is our end. So there's 3 pi by 4, 11 pi by 4. Which is 8 pi by 4, which is 2 pi. So K is 2 pi divided by the period, which is 2 pi divided by 2 pi, which is just 1 in this case. And again, breaking it down into those steps, the A, the K, the C, and the D, focuses what you have to work on and what you have to do. And then you just write out the equation. Obviously, you don't really need the K value in there. Okay. All right. So that was, you were given the graph and you had to come up with the equation. Now we're given the equation and you have to come up with the graph, and it also says to do the range and interval of increase and decrease, and I always forget to do those in this question, so hopefully I'll remember. And again, this always comes down to the A, the K, the C, and the D. So write them out. A is -3. K is 1/2. C is -pi by 6. D is 1. X plus pi by 6 is a shift to the left, which means C is negative. And we take these 4 values and use the 5 key questions to turn them into the properties to allow us to draw the graph. So I usually start with the 0 line, which comes from D. Y equals 1, yep.
No.
Oh, you don't have a question? And then I do amplitude. Amplitude is always positive. You may make yourself a note that there's a reflection. Try not to forget that. It's easy to forget. From the 0 line and the amplitude, we can get the max and the min. So the max is the 0 line plus the amplitude, and the min is the 0 line minus the amplitude. And remember, order there matters. You can't subtract the other way. You always start from the 0 line, and I think of it that way. I start from the 0 line, and I go up to the max and down to the min. Visualizing it like that hopefully helps you remember the order that those have to be in. So 4 and negative 2. The start is the c value, negative pi by 6. Again, x plus pi by 6 is a shift to the left. Pi by 6, so the start is negative pi by 6. The period is similar to finding the k value, but in the opposite direction type thing. 2 pi divided by k. K is a half, 2 pi divided by a half, so that's 4 pi. And then the end, is the start plus the period. So negative 1 pi by 6 plus 4 pi. If you have a calculator that can do fractions, then you might just be doing it that way. Otherwise, we're turning 4 pi into 24 pi by 6, which gives us 23 pi by 6 as our end. And that's going to be our check after we've done everything to make sure that we've got it right. Some people, graph this differently, and some people in this class were graphing it differently, where you plot the start and plot the end, and then find the halfway point and find the other halfway points. Like that works too. So then it's not a check, but you need it because that's where one of your points is. Okay, good. Now we have to find our scale. This is the hard part. Some questions are harder than others. You take the period and divide by 4. Always divide by 4. 4 pi divided by 4 is pi. Then you compare it to the phase shift, which in this case is pi by 6. We don't really care if it's positive or negative, but then you get a common denominator between those two values. What's the lowest common denominator between pi and pi by 6? Pi by 6. So you have to go at least pi by 6. You can make the scale smaller, which will stretch your graph out more. But you can't do anything bigger than pi by 6. Now we forget about the phase shift, and we're just looking at those two numbers. And if we're counting by pi by 6s, it would be 6 squares to go between points. Because I have to go pi, and I'm counting by pi by 6s. Starting to come back, starting to refresh your memory about doing all of this. But it's like I said, it's amazing how, it feels like a long time ago that we did this, and you were good at it at the time. You're like, oh my gosh, yeah, that's right, we did this and we did that, and it's amazing how much stuff we've done in this course, right? If I made pi by 6 2 squares, that would double it. We'd have to go 12 squares between points. Well, there's no way that's going to fit on the graph. So we have to make this 1 square. That will give us 6 squares between critical points. That's the hard part. Hard part's done. The rest is supposed to be easy. We have to label our scale, but we've already decided what the scale is going to be. 1, 2, 3, 4, 5, 6 to pi means 3 to pi by 2. So every 3 squares I'm counting a pi by 2. Every 6 squares I'm counting a pi. This is going to be negative pi by 2. 3 squares back. 1, 2, 3 is 3 pi by 2. 1, 2, 3 is 4 pi by 2, which is 2 pi. 1, 2, 3 is 5 pi by 2. 1, 2, 3 is 6 pi by 2, which is 3 pi. 1, 2, 3, 7 pi by 2. 1, 2, 3, 8 pi by 2, which is 4 pi, and that's far enough. And vertical scale, I'm going to count every 2 squares is 1. Like that. Like I said, all the hard part is done now. All the work is done. Now I just go and read the properties that I need to get started. This is sine. Don't forget it's got a reflection. Sine starts on the 0 line. And at the start, so the 0 line is 1. And the start is negative pi by 6. So I go to 1 and negative pi by 6. And there's my first point. If you're doing the counting squares method, sine usually goes to the max. But this is reflected, so it goes to the min. Again, we've already figured out what the min is. It's negative 2. So I'm going to go to negative 2. 1, 2, 3, 4, 5, 6. Back to the 0 line. 1, 2, 3, 4, 5, 6. To the max, which is 4. 1, 2, 3, 4, 5, 6. Back to the 0 line. 1, 2, 3, 4, 5, 6. That is indeed 23 pi by 4. It's 1 back, or sorry, 23 pi by 6. It's 1 back from 24 pi by 6. So I'm in the right spot. Okay, and now we just try to draw a nice graph. Everybody good with that one? Oh, almost forgot. I remember this time. Range, intervals of increase and decrease. I'm not really sure whether there's space to put this, but I guess we'll do it over here. So range, that's just the min to the max. Intervals of increase. This can be a little bit tricky, and decrease because I got to go back and find all these other points, right? It's a bit harder for sine because it's got more changes. Let's do it like this. Increase and decrease. So we start with a decrease, negative pi by 6. 1, 2, 3, 4, 5. That's 5 pi by 6. So negative pi by 6 less than x less than 5 pi by 6. And then it increases from 5 pi by 6 to, let's see, this is 12, 13, 14, 15, 16, 17 pi by 6. So that's increase, 5 pi by 6. What did I say, 17? Yeah, because it's 1 back from 18. If those points fall right on your scale, it makes it a lot easier. This is one of the harder ones where you got to figure out what all those points are. And then 17 pi by 6 to the end, which is 23 pi by 6, is an interval of decrease again. Okay? This is similar to question number 2 from the first page, but what's different about it? Evan? This is a calculator question. The other one was special triangles, exact value. This one's not exact value. Use your calculator. So theta related is shift sign or inverse sign or arc sign. Notice that we don't include the negative when we put it into our calculator. 0.6763. I'm keeping 4 decimal places, but really I'm going to keep that answer on my calculator so I'm not rounding until the very end. And that way I know that my answers will be perfectly correct to 4 decimal places. It doesn't say in this question, but usually we do 4 decimal places. This is where the sine comes in. And I mean this sine, not sine. Where we use the cast rule to see that it's sine and it's negative, so it's quadrants 3 and 4. So we already did this one. Theta in quadrant 3 is pi plus theta related. So I'm going to go plus pi. And I got 3.8179. And theta in quadrant 4. There are tricks that you can do to kind of be efficient with your calculator. And one of them is, if I find quadrant 3, I can subtract pi to quickly get back theta related. Don't overthink it. It's not that big a deal to just put shift sign of the ratio that you're given in the question. That's almost as quick, right? So, but there are ways that you can be efficient. And in quadrant 4, what is it? How do we find 2 pi minus theta related? Very good. Oops. 5.6069. Questions about that? That wraps up Unit 4. Okay, Unit 5. So, first question here, we've got a pi by 12 and a pi by 8. These were Unit 5 questions. Pi by 12 is the compound angle question. Pi by 8 is the double angle question. These are very specific. There's a very strict sort of set of steps that you can go through to solve these questions. And if you forgot them or you didn't know them, it's probably not the kind of thing that you're going to be able to figure out. There's not another way of solving these. You have to use the method that we did in class. Okay? And if you remember, let me go find it. The pi by 12s have to do with this little chart, right? This is the first step, those are the options and they continue, but those are the numbers that we're allowed to use. We're really just looking at the numerator, the pi over 12 part we can kind of ignore. What happened? So I'm looking for 2 numbers in that list that add or subtract to 17, and I'm going to use sine of 8 pi by 12 plus 9. 8 plus 9 is 17. That part's supposed to be easy. Sometimes people get a little stuck on it, but it's supposed to be easy. You're just looking for numbers that add or subtract, and there's not really a better choice than any others. Whichever ones you pick are fine. Then I have to simplify each of these. Again, if you have a calculator that does that, your calculator can do it. I don't reduce it to pi over 3. It's got to be 2 pi over 3. That part matters. So it's 2 pi over 3 and 3 pi over 4. Next step. Like these are the steps. Find your numbers. Step 1. Reduce them. Step 2. Step 3. Expand with the formula. Do you remember the compound angle formula for sine? Yep.
It's sine A cos A cos B.
Good.
In this case, plus sine B cos A.
Good. Next step is evaluate each of those. And this is where in the course you may have found that you started to memorize these more than having to draw out the triangles and stuff. Back in Unit 4, calculating the sine of 2 pi by 3 was like took some work. And then by the end of Unit 5, you're kind of like, holy cow, this is easy. I can just whip these out, right? Or at least some people feel that way. So we're going to do these quickly, but you are still taking cast rule into account and the special triangles and thinking about all of that, right? So this 2 pi by 3 is quadrant, yep.
Why are there 3 pi by 4?
Oh, thank you. I don't know. Thank you very much. Okay. 2 pi by 3 is in quadrant 2. 3 pi by 4 is also in quadrant 2, so they both happen to be in quadrant 2. Sine is positive in quadrant 2, so this is root 3 over 2. Cos is negative 1 over root 2. 3 pi by 4, again positive because it's sine. Cos is negative. So, and then final step is to simplify. And these questions always have 3 plus 1 or 3 minus 1 or negative 3 minus 1 or 1 minus root 3 or whatever on top and 2 root 2 on the bottom. They always look the same. Okay? And then the pi by 8s, like I said, these are the ones that are double angle, and getting it set up in the beginning is really important. There's a trick to make sure that we get it set up properly, and that is that theta equals 5 pi by 8 and 2 theta. And I always write this off to the side, and I think some people try to do it in their head. They don't write it down, and they make a mistake. So it's always a strong suggestion that you actually write this down off to the side somewhere. So the 2 and the 8 now simplify, and 2 theta is 5 pi by 4. Then we use one of the cosine double angle formulas. There's 3, but there's only 2 of them that we use. And we use the one that we're searching for. So if it's a cosine question, we use the one with cosine. If it's a sine question, we use the one with sine. And so for cosine, it's 2 cos squared theta minus 1 equals cos 2 theta. So theta is pi by 8. I'm just subbing in. 5 pi by 8. And 2 theta is 5 pi by 4. That's the setup. This is the important part. The rest are just kind of step-by-step things that you do, and there is a little bit of tricky fraction stuff and everything, and you got to watch for a couple of little things. But the setup to me is the important part. I'm going to evaluate cos of 5 pi by 4. You could do this and start moving stuff around to sort of do it in fewer steps. But sometimes people try to do too many steps at once and they end up making a mistake. Now we're just moving everything over and isolating for the 5 pi by 8. So I'm going to add 1 to both sides and divide by 2. Now I'm going to take the square root of both sides. Don't forget the plus minus. And I'm also going to start simplifying. I'm getting a common denominator on top. So root 2 over root 2. Or you could look at it as multiplying by root 2 over root 2. So root 2 times 1 gives me root 2. Root 2 times negative 1 over root 2 gives me 1. If you do the common denominator way, turning a 1 into root 2 over root 2, you might need 2 steps, whereas this is only 1 step. And then what do we have to do? Evan.
Determine the quadrant that cos 5 pi by 8 is in.
Yeah, because we got the plus minus because we took the square root, but really it's only one of them. We can figure out if it is positive or negative because we know we can figure out what quadrant we're in. 8 pi by 8 would be 1 pi. So we haven't got that far yet. We're not bigger than 8 pi by 8. We haven't gone past the x-axis. 4 pi by 8 would be pi by 2, so we are past that. So we're in quadrant 2. Cosine is negative in quadrant 2, so remember the expectation was you circle and cross out and state the quadrant. You have to state the quadrant as well. So cos of 5 pi by 8 equals negative square root of root 2 minus 1 over 2 root 2. And again, those questions always look the same except for possibly a positive or negative that changes. Any questions about any of that? All right, moving on to an identity. If you want to get started, so it just says prove the following identity. You can take a second and get started. We did a lot of work on identities, and you probably remember, or you will once I remind you, we always start by making observations. What do you notice? What's relevant? What tells us, gives us an idea of what our first step might be? You're looking for things like, do you have reciprocals that you can swap to sine and cosine? Are there squares in there? So you might be using Pythagorean identity, right? Which both of those we don't have. What do we have? What do you notice?
Well, there's an x and a y.
So not double angle, but compound angles. Okay, that's a big indicator of what we're going to do first to start this question. Notice anything else? And remember, these observations are not a matter of right and wrong. I mean, it could be wrong if you said, there's a tangent. There's no tangent in it, but...
It just equals cos x, so maybe like you have to simplify it.
Yeah, so right. So the right side is very simple. It's just cos x. What are you going to do with that? Nothing. We're not going to change it to secant or something weird like that. Like the right side is going to be no work, and the left side, you're exactly right, is going to end up simplifying down to cos x. So that's something to be aware of, just that the right side is very, very simple. Okay, let's get this one set up. So we've already established that we're doing all the work on the left side. I've got compound angles, but on the right side I've got just a single angle. So we're absolutely going to be expanding using the compound angle formula. So this is cos xy times cos y. So I need to keep them in brackets. Whoops, what's going on here? So this is cos x cos y minus sine x sine y times cos x or y. That could be a mistake that somebody would make, not putting this in brackets. Sine x cos y plus sine y cos x. Times sine y. What do you think we're going to do next? And remember, until you get really experienced at these, you get this hesitation. Well, you could do this, but I don't know if it's right. And I don't want to do it because I'm not sure. But you gotta tell that voice inside your head to go away, because you got to do something. And there's a good chance whatever you're thinking is right. I don't know what you're thinking right now, but I look at this and I say there's only one thing you could do. So you may not know that it's right, and you may not know how it's going to work out, but you might as well try it unless you got a better idea. What else could you do? So what are we going to do here?
You're going to multiply the cos y and the sine y into the...
Yeah, we're going to multiply these in like that for both of them. So this is cos x, cos y times cos y, so that's cos x, cos squared y, minus sine x, sine y, cos y, plus sine x, cos y, sine y. And then sine squared y, cos x. And now we got to sit back and make some observations again and see what's going on here. What's happening?
Well, those middle two terms cancel each other.
They're the same. They're slightly different order, but they've got the same three parts, both of them, right? One's positive, one's negative. So they add to 0. That should make you feel like you're on the right track. We're not done yet. Sometimes after one or two steps or one or two sort of operations like that, things just kind of fall into place, but we still got to do a little bit more work here.
You can factor out the cos x.
And the reason why I like this, you can factor out the cos x. The reason why I like this is cos x is the right side. I don't know that that means we're necessarily doing it right, but it kind of makes me feel like, okay, that we're onto something here. You know what I mean? So factor out cos x. And then finally, go ahead.
The Pythagorean stuff.
This is, yeah, the Pythagorean identity, that's 1, so it's cos x. Obviously, you don't need to write this. Whoops, cos x times 1, which is cos x, which is our right side. And we're done. I really like this one. It's a really good example. You know, it's got a little bit of the grade 12 stuff because it's got that compound angle, but then it's got that expanding step where you have that hesitancy. I don't know if this is the right thing to do. It's a little bit hard to see early on how it's going to play out, so you have to have that confidence to get started. It's got a little bit of factoring in it, and it ends up even having a Pythagorean identity, so it's got a little bit of everything. I really like that question for that reason. Okay, next page. We got a couple of trig equations here. How do we start this one off? Yep.
Bring all terms to one side.
Get everything on one side, set it equal to 0. Very good. There are cases where you don't do that, but not with the trinomial ones. So plus 2 equals 0. Again, notice we're in the normal domain, nothing weird going on there. Lots of different types of these. It's not a reciprocal. It's not a swap out where you've got sine and cosine. Again, we're doing some observations, kind of like we do with identities. It's a trinomial. We're going to end up either factoring or using the quadratic formula. It's not a double angle. That was the other type that we did. That's what question 4 looks like. Okay, so it's a straightforward trinomial. B squared minus 4AC works out to 11 squared minus 4 times 5 times 2. 81. Therefore, factorable. 81 is a perfect square. It's 9 squared. So therefore, we can factor it. Looks to me like it's going to be 2 and 1. So I get 10 and 1, which adds to 11. And everything's negative. Negative 1 times negative 2 gives the positive 2. Negative 10 minus 1 gives the negative 11. All right, somebody tell me something about cos theta equals 2.
It's extraneous.
Yeah, we don't usually use the word extraneous in that case. It's just there is no solution, there is no time, there is no value of theta where cos of theta will equal 2. So we write no solution. We probably, you wouldn't say extraneous just because that's not an answer yet. If you had theta equal something, but for some reason it was extraneous outside the domain or something, you would say that. Okay, and then this one, again, is not an exact value type. Remember, the expectation was if you can do exact value, you do. If you can't do exact value, then it would have been rounded to 4 decimal places. So we put it into the calculator, shift cos 1 divided by 5. Hopefully my calculator is in radians, and it is. Its cosine is positive, so we are in quadrants 1 and 4. So 2 pi minus theta related 9137. It's been a while. If you were a little bit stuck on this one because of the factoring, the trick is on scrap paper, write it out like this and factor it like that. Right? If it's the cosine part that's kind of causing you to get confused. All right. Solve for theta if tan 2 theta equals 0.7138. So another not exact value, non-special triangle. This one's double angle. So there's an extra step at the end of these questions and a couple little common mistakes that you could make. Same first step, find our related angle. And in this case, it's called 2 theta all related. It's not 2 times theta related. It's 2 theta all related. Shift tan 0.7138. So 0.6199. You don't divide by 2 here. You have to split it up first. We're in quadrant 1. Because tan is positive there, whoops, 0.6199. And in quadrant 3, because that's where tan is negative, so pi plus theta related. Now we can divide by 2. And it's best to do sort of go down one side and then go back to beginning and go down the other side, just because then you can keep it on your calculator. You don't have to keep retyping stuff in. So just because I've got this one on my calculator, I'll do this one first. So whoops, now we can divide by 2. How do I get the next answer? By adding pi. Okay, and then I'm just going to go back up on my calculator here to get back to that original one. So now I've got this number as my last answer. I just go up to it and hit equals again. Divide by 2. That's a tricky little rounding job there. 3100. You need the 2 zeros if it's to 4 decimal places. .4510. 6. So 4 answers. It's really helpful if you are expecting how many answers you're going to get to these kinds of questions. So that, you know, if you only get 2, you're like, I think there should have been more. What am I missing here, right? So it's a good idea to kind of know that. Yep.
Why do you spell 0.6199 as one of the answers?
Oh, I don't know. Thank you.
Yeah.
0.3100. The other ones are right? Okay, good. All right. Couple more questions from Unit 5. This is one of those Sir-Kix-or-Tix questions. It's giving us some information by telling us the value of sine theta and telling us what quadrant we're in. So from 3 pi by 2 to 2 pi is quadrant 4. Sine is negative in quadrant 4. We take this information and we split it up into sine theta is y over r. So I know y, is negative 3. R is 5. How do we find x? Pythagorean theorem. R squared minus y squared in this case. 25 minus 9 is 16. Square root of 16 is 4. Is x positive or negative in quadrant 4? That's the last thing that you have to think about here.
Negative. No, never.
Positive, yeah, good. Okay, you changed your mind to positive, yep. So it should be positive 4. Cosine is positive in that quadrant, so x has to be positive so that it works out that way. I like to write these all back out. Then you don't have to go back and make them up every time. You've just got them right there. Remember, there were questions that we did that were a little bit harder because it had a theta and an alpha. It had 2 angles. So you have 6 ratios that you might be working with. Okay, and then in this question, it's sine 2 theta, cos 2 theta, and tan 2 theta. So we're just using the double angle formulas, sine theta, cos theta. And I know sine theta. And I know cos theta. 2 times 3 is 6. 6 times 4 is 24. So this looks like negative 24 over 5 times 5 is 25. Cos 2 theta has 3 versions. Pick your favorite. I don't think any one of them is easier than any other, but some people might. So again, cos theta is 4 over 5. Sine theta is negative 3 over 5. This is 16 over 25 minus 9 over 25. So 7 over 25. Now, if you were smart, and unless the question was somehow awkwardly worded to say you're not allowed to do this, it could say use the double angle formulas only. But you could just do sine over cos, right? And it would simplify really easy. I'm going to use the tan formula because We haven't seen it in a while. So the tan formula is 2 tan theta over 1 minus tan squared theta. If you remember from up above, tan is negative 3 over 4. So that's going to be negative 3 over 2, simplifying that. You could put this whole thing into your calculator all in one shot. And this is going to be 16 over 16 minus 9 over 16. Uh, 7 over 16. And I believe, putting this into the calculator, it works out to negative 24 over 7. Which, just looking at the other two answers, makes sense. Hopefully at that point you can put it in your calculator. Yeah, 3 times 8, it ends up being 3 times 8 on top over 7. Okay. All right, last one from Unit 5. GCI has a Ferris wheel. I bet you didn't know that. It's out back. It's called the Ferris wheel of doom. It has a radius of 20 meters and makes one complete revolution every 60 seconds. It's a Ferris wheel of doom because it actually rolls down the hill and into the river. So it's fun, but you only get to take it once. Every 60 seconds, if a rider gets on at the bottom, which is 1 meter off the ground, sketch a graph of 2 complete cycles of the wheel. Oops. Okay, so I'm going to call this H for height. And we're in meters. And I'll call this T for time in seconds. And again, I like to give myself sort of little tick marks using the ruler just so that I can keep things kind of to scale just generally. Otherwise, it can be kind of hard with these questions to keep things let's see. So if I go 1 minute. No, it's not going to fit, so I'm going to have to keep this one kind of small. 30 seconds, 60 seconds, 90 seconds, 120 seconds. So we're starting at the bottom. The bottom is 1 meter. It has a radius of 20. What does that tell us?
It's 40 meters tall.
So it's very good. It's 40 all the way to the top, but that's starting at 1, so the top will be 41. And it can be helpful to put the middle there as well, just for reference. So it's going to be 21. From 1 up the radius to 21, up the radius again to 41. One complete cycle means it'll be back to the bottom here, and then back to the bottom here, and it'll be at the top here, and at the top here. Like that. Write an equation that relates the height of the rider above the ground with the time that the rider has been on the ride. So again, equation means we're doing A, K, C, and D. And again, I would say we've done most of the hard work. When we make that sketch, the point of making the sketch is it forces us to think about the properties that turn into the A, K, C, and D. So A is going to be negative because it's reflected. And it is the amplitude half the distance from the max to the min. We've already done that. We went up 20 and then up 20 again, right? So it's 20, negative 20. C is 0. D is the 0 line. Again, we marked that, so it's 21. K is the only one that requires a little bit of work. So it's 2 pi divided by the period. The period is 60 seconds. That was given in the question. Simplify that to pi by 30. And then just write it out. Everybody good? Finally, find the height of the height above the ground of a rider who has been on the ride for 20 seconds. So again, now we're just using that formula. Once again, make sure your calculator's in radians. I usually like to do this. Oh my gosh, I'm getting myself mixed up here. 20 pi divided by 30. Just because there's an error that you can get if you type it in the way that the calculator doesn't like. So I just find that's sort of the easiest way to do it. Make sure I get the right answer every time. Plus 21. 31, exactly. And then you'd probably do your therefore statement, blah, 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 blah. Okay. Does that answer make sense? If there's ever a way to check your answer, why wouldn't you? It only takes a second. Where's 20? Somewhere around here. Around 31. Yeah, it's reasonable. If I got an answer of 10, I'd say, wait a minute, that doesn't make any sense. If I got an answer of -5, I'd say, wait a minute, that doesn't make any sense. Right? So you can kind of check your answer if you've got a decent sketch. Check that it's more or less correct. All right, we're almost done. On to Unit 6. There's no review for Unit 7 since we just finished it. 3 quick questions. Question A is an exponential equation. We're going to solve by taking the log of both sides. Question B is a logarithmic equation. We're going to solve by putting it in exponential form. Sort of. All right, let's get to it. So take log of both sides. Now, if you remember, you can do some of the steps to simplifying at the same time as taking the log of both sides, but just because this is review, I'm going to take it a little bit slower. So I use the property of logarithms where if I have a product in the argument, I can split that up into the sum of 2 different parts. And I'm going to bring down the exponent at the same time. So log of 5 plus x plus 4 log of 2.7. You need brackets around that x plus 4, and we're going to have to distribute it. Okay, that could be a common mistake. Log of 3 plus and 5x minus 1, oops, log 4.2. Next step is to distribute. This one one's a beast. This one's got everything. Like it's as long as they get. We've got 3 terms on each side. They're not usually quite that long and large, but it doesn't really make it that much harder. It makes it a bit longer, I guess, like to write it all out, but it's the same kind of steps every time. What do we do now?
But the terms with x as a coefficient on one side.
Yeah, very good. We want to get the x's on one side and all the rest of the junk on the other side. So x log 2.7 minus 5x log 4.2 log 3 minus log 4.2 minus log 5 minus log minus 4 log 2.7. Order doesn't matter here. You can do it whatever order you want. You could multiply both sides by -1 and change more things to plus, but there's not really a point in doing that. Now we factor out the x. It would probably be easy to factor out the x and divide in the same step, because instead of writing it out in brackets, just write it in the denominator on the other side, right? Again, save yourself a step, because this one's a pain to keep writing out. And you got to make sure you know how to put these into your calculator correctly. It's a long one to put in there. If you have that fraction button, it makes it a lot easier. If you don't, make sure you have brackets around the top and bottom. Make sure you close all your brackets. When we took the log of both sides, we chose base 10 because it's easier to put in the calculator. Oops. 5 log 4.2. Okay, if you didn't get a chance to try it, you can try that later and just make sure that you can get the right answer on your calculator. All right, and this is the type where we use the log properties to put these together on one side. And I'm going to do it this way, where I turn the right side into a logarithm, log base 3 of 3, and that number goes into the exponent. And I chose 3 because that was the base of the other part of the question, right? And it's always 3, it's always the same number. And now that I have log of something equals log of something, same base, I can say those somethings are equal. So therefore, 2x plus 1 times 5x minus 1 equals 3 to the 1. The other way of thinking about this is we're rewriting it in exponential notation. It's up to you which way you look at it, which way you do it. So you end up at the same place. Now it's a grade 10 question. We expand and simplify. 10x squared. So I've got 5x minus 2x. Move everything to the left side. B squared minus 4ac looks like 9 plus 4 times 4 times 10, which is 160 plus 9, so 169. And that means factorable again. It's 13 squared. Okay? Otherwise, you'd be doing quadratic formula, and we did see those kinds of questions both in trigonometry and in logarithms. It's got to be 5 and 2, don't you think? And I think the other one's actually 4 and 1 though, because it is 8, positive 8 minus 5 gives the positive 3, and 4 times negative 1 gives the negative 4. And there was something that we didn't do at the beginning that we probably should have done. What was it that we have to go back and think about now?
State
The restrictions, yeah, that's right. So x has to be greater than negative 1 over 2. That's from the first bracket. And x has to be greater than a fifth, because the argument has to be greater than 0. If it has to be greater than negative a half and greater than a fifth, then that's the only one that we really care about, which means the negative 4 over 5 is extraneous, but the 1/2 is fine. And again, that often happens, where you calculate 2 answers, but only one of them is good. But you can have 2 answers. That can absolutely happen. All right, ready? Last question. Traces of burnt wood were found. Everybody good? Everybody ready to move on? Okay. Traces of burnt wood were found in an archaeological dig in Chile. The wood was found to contain approximately 1.67% of the original amount of carbon-14. If the half-life of carbon-14 is 5,730 years, approximately when was the wood burnt? These questions are so cool. When we did all of these different exponential applications in Unit 6, it's interesting because these are real applications. This is actually how they know how old some civilizations like of humans are, right? If they find a tool and they can date it and they use this math to do it, this is stuff that people really do in the real world. Archaeologists that are out there doing this stuff all the time. And they can learn about our past, our history, when we started using tools, when we started having fires and using fire. Like they can figure all this stuff out literally with this math. It's really, really interesting. So half-life, we usually use m for mass. Half-life questions, B is always a half. T is what we're looking for. What's N?
5,730 years.
Yep, the length of a half-life. What about M and M naught?
1 and 0.000167.
Good. I'm going to do it a slightly different way. The easiest way is if you start with 100% and you end with 1.67%. But if you do it your way, you skip a step. So if you can do it like that, you could. You might as well. Okay? Especially since the percentage that's remaining is already a decimal. That might be enough that some people are going to get the zeros out of place or whatever. So 1.67 equals 100 times a half to the t over 5730. And once you get it set up, it's the same steps every time. Divide by that coefficient. 1.67 divided by 100. This is where people could get the zeros out of place. So, if you have to use your calculator, do it. Now we rewrite in logarithmic form, or you could take the log of both sides. Now I multiply both sides by the denominator there. And if you have to use the change of base formula because of your calculator, then that would look like log of 0.0167 over log of 0.5. it says round to the nearest year, I believe. 33,830. Whew, that's old. And again, you do a therefore statement, blah, 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 blah.